Content analysis is a popular research method for businesses and social scientists. The purpose of the content analysis is to literally determine whether something is present or not. This may be words, pictures, design features. For example, imagine that you're working on an advertisement and you're advertising a product that your company has in competition with other companies. So not only do you need to make sure that your advertisement is catching, but also that it uses a different type of persuasive appeal than other ads of the same product on the market. You would then do a content analysis of all of the advertisements for the same type of product to see what sort of persuasive appeals are being used. Then you can design your advertisement to appeal to those people who are being overlooked in the other ads. So the process of a content analysis. First, you identify the universe of your content. Are you looking at a specific type of advertisement? Are you looking at social media posts associated with a specific hashtag? Are you looking at words from a series of speeches? Any media can be subject to a content analysis. Next, you take a sample of that content to be analyzed. Identify the coding used you under. Is it words? Is it themes? Is it characters on the page? Specific items? Is it the use of space? Is it the use of time? Then you determine specific categorical coding schemes, something that you and other researchers can use together to determine whether or not a content is present. Then you train researchers on this coding scheme you developed. You pilot test that coding scheme. Then you come back together, compare your results of that pilot test to see if you need to refine the coding scheme. And once you're confident that all of your researchers understand the coding scheme and that the coding scheme works well, you analyze your data. Let's look at an example to make that a bit less abstract. Let's do a content analysis of skin cancer PSAs. I went to Google Images and copied the first 3 skin cancer PSAs that popped up below in this slide for us. A lot of health communication scholars are talking about skin cancer right now because the demographics at risk of skin cancer have shifted drastically over the years. PSA designs really haven't. So let's develop a coding scheme to look at what is present and what is not present in a skin cancer PSA. So what do I see here? Just looking at these 3, well, I see people of various ages. The gentleman on the right looks like he might be at the pool. The child looks like they may be at a beach. There's some sort of texturing in the background. Anything that you observe can be included in a content analysis coding scheme. Here's what I would put together based on what I see. Is there a person? Yes or no? What's their age? What kind of background are they on? And what's their biological sex? I'll give you a hint about content analyses to make your life easier. Sometimes you need to give yourself a range of options. For example, if you look at the young man on the right, we could probably guess fairly closely what age we think he is and yet not guess exactly the same age. I would say perhaps 28. Maybe you would say 26. Maybe you would say 30. We wouldn't be completely off, but we also wouldn't be consistent in our content analysis if we had to give a specific year. So here's how I might set this up. Say, is there a person? Yes or no? What's their age? Less than 18? 18 to 35? 36 to 55? Are they at a pool? Are they at a beach? Is there some sort of texture background instead? And what's their biological sex? Are they male, female, or like the child in the lower left-hand corner of the screen, is that information indeterminate? Let's test this coding scheme together. In the next 5 slides, you'll see 5 separate PSAs, again pulled from the top of Google Images. To help yourself, set up a table looking something like this so that you can have one PSA represented in a row or a column, depending on how you like to set up your table. Pause this video to set up a table for yourself. Okay, let's get started. If you haven't already filled out this table in the PSA 1 column, go ahead and do so. Here's how I would fill out column 1. Yes, there is a person. I would guess that they're 18 to 35 years old. The background, I'm not sure about. They could be on a a pool, or a towel at the beach. So already I'm seeing an issue with the coding scheme I designed because I don't have an option to say indeterminate there. I would also say this is a female. Although perhaps I should say indeterminate. I can't see a face. I can't see any other features. Maybe this is another problem with my coding scheme. Oh, let's look at this one. Again, pause the video and fill out the coding scheme according to your observations of PSA 2. Here's how I would fill out this PSA. There's no person, and again, I see another problem. I don't know what to say in terms of age. I didn't give myself an indeterminate option, and there's no one here to age. The background is a texture though, but like age, what do I do when there's no person in which to determine the sex? All right, now fill out your table for PSA 3. I would say that yes, there's a person. She's 18 to 35 years old, at the beach, and female. All right, let's try PSA 4. Pause the video and give it a try. I say yes, there's a person. The age, I don't know what to do because if you look closely at the PSA, the person who's the target of the message, the person who was affected by skin cancer, is represented in that photograph. And she looks significantly older than the person holding the photograph. So I haven't given myself an option in this coding scheme for multiple people either. I do have a texture background, and both of the people depicted in this PSA are female, so at least I can respond for biological sex, but I'm seeing another problem. All right, last one. How would you fill this out? Pause the video and give it a try. I find more problems for myself. Yes, there is a person. I don't know their age. I don't know what to say about this background because I would say it's clearly a hospital, but that's not one of our options. And the sex, I would have to say that's indeterminate. All right, now stop. Now this is where we would go back and fix our coding scheme after having done this pilot sample. We'd come together, you and I would sit down and we would talk about all the problems we experienced. Clearly, one of the first things that needs to be done is adding indeterminate options. We would also need to set out rules as to when we decide whether or not something is indeterminate. For example, perhaps we don't want to identify someone's age unless we can see their face. We may need to add additional columns for if there are multiple people. Perhaps we should be asking about what the average age is or what the sex of the majority of people were depicted is. Once we got that fixed, we take another small sample and code it independently. If we found that it was easier to use, we didn't have problems, and we came up with the same answer, then we would go out and we collect our large sample, or if there was a limited number of PSAs available, we would select the entire population of skin cancer PSAs and code those independently. This process of ensuring that our coding scheme works consistently and that all coders know how to use it well is how we establish validity. After we've analyzed the data independently, we need to come together and establish our intercoder reliability. When you only have 2 coders, the most popular way to do this is Scott's pie. Here's the formula for Scott's pie, if you want to pause for a second and take a look at it. There are other ways to calculate reliability though. One of the easiest ways for us, since we're now savvy at using SPSS, is to just use Chromebox Alpha. If there are only 2 of you, you put the data from coder 1 in column 1, the data from coder 2 in column 2, and calculate the Chromebox Alpha between those 2 columns. If there's more of you, then you just need to input the data from each coder in its own independent column. The only intercoder reliability analysis that you see in publication at times that I strongly encourage you to not use is percent agreement. Percent agreement really isn't an acceptable way to establish intercoder reliability simply because it doesn't take into account how often you would agree based on chance alone. Because of that, it's very, very weak. So if there's only 2 of you, again, Scott's pie is very popular, but if there's more of you, Chromebox Alpha is really the way to go.